Hey there, in this video we are going to talk about quadratic functions. Specifically, we're going to look at the graphs of a quadratic function and see how the numbers in the equation can tell us things about what's going on in the graph before we even plug that into some kind of graphing technology. So first, let's go over the graph itself and the parts of it. So a quadratic function gives us a parabola, like the one we see here. So it's this nice U shape that we get whenever it's a quadratic. So my leading term is an x squared of some kind. So a quadratic parabola has a vertex, and that's going to be the lowest or highest, if it's opening downward, point of the graph. We call that the vertex. There is symmetry between the two sides of the graph going through that vertex. So whatever the x value is for your vertex, the equation of that vertical line will be x equals that x coordinate. That is the axis of symmetry. So if I draw a line through the vertex, I get a mirror image on each side of my parabola. And some other important points that we usually are looking for when we want to graph these by hand is the x-intercepts and the y-intercepts of the parabola. And it really helps us just get the shape, identify whether it's opening up or down, and that kind of thing. So there's a couple of different ways that you might see the equation of a quadratic. One of those is the general form. The other is the vertex form. The general form is what we're more used to dealing with. It's a form that makes it easy to factor a quadratic, and we can find the axis of symmetry using this formula, where the axis of symmetry is going to be x equals the constant that you get from taking negative b over 2a. So if we have this quadratic ax squared plus bx plus c, you grab those constants from the two x terms and plug it into this formula, and that will give you the axis of symmetry. It also gives you the x coordinate of the vertex. And to find the y coordinate of the vertex, well, you can just take that x value and plug it into the equation and solve for y. The other form that we will sometimes see is called the vertex form. And this is a nice way of writing it because you can see the actual x and y coordinates of the vertex in this equation, in this form. And there's not really any calculations that you have to do if you're given the equation in this form. So it's a really nice one for that reason. And so it's f of x equals some constant a times x minus h squared plus k. Notice that it's a minus h in there. So if I have a positive, if it's x plus something, then the negative of that number would be my axis of symmetry. So x is going to be equal to h. It's also the x coordinate of the vertex. And then the k that's hanging out at the end of the equation, that would be the y coordinate of the equation. Okay, so these are the two different forms and the ways that you would find parts of the equation and the graph from those forms. And something to note that the vertex is either the absolute maximum if the parabola is opening downward, or the absolute minimum if it's opening upward when you find these. So that's something else you might be asked for is what is the absolute maximum or minimum? Well, it's just going to be the vertex, and whether it's a max or a min depends on whether it's opening up or down. Okay, so let's do some examples with this. This first one is in general form. I have f of x equals 3x squared plus 12x minus 8. And we're going to find everything we can. We're going to find the vertex, the axis of symmetry, the intercepts, and the absolute extrema. We're going to sketch a graph of this thing, and we're going to determine the domain and range of the function. So first, just a refresher on those formulas from the last slide. When it's in this form, this general form, the axis of symmetry and the x coordinate of your vertex is going to be negative b over 2a. So that's what I'm going to start with. For this one, a is going to be 3 and b is going to be 12, just pulling those from the coefficients of the two x terms in the quadratic. And plugging those in to the formula, I get negative 12 over 2 times 3, which simplifies to negative 12 over 6, which is negative 2. So the x coordinate of the vertex is at negative 2. And to find the y coordinate, I will plug this into the quadratic and evaluate it at negative 2. So y is going to be equal to f of negative 2. And if I start plugging that in, I have 3 times negative 2 squared plus 12 times negative 2 minus 8. Plug that all into my calculator, and I get negative 20. Okay, so visualizing this, I have a vertex that's 2 to the left and down a negative 20. So it's somewhere down in that third quadrant that I have my vertex. I don't know much more at this point about whether it's opening up or down. I do know that the axis of symmetry is x equals negative 2, that same value. So I found the vertex and the axis of symmetry. Next up, let's look at the intercepts. And this will help us figure out whether it opens up or down, depending on where it is in relation to the vertex. So intercepts, of course, is when we start plugging in 0 for either x or for y. So let's start with plugging it in for x to get the y-intercept. So f of 0 is going to give me negative 8, which means my y-intercept is at 0, negative 8. So that's much higher up than the vertex. So I'm thinking this is going to be opening up if I'm kind of visualizing how this parabola is going to be looking. Next is the x-intercepts. You should usually get 2 of these, assuming there are real numbers for this. So I'm plugging in 0 for y and solving for x. If you can factor it, factor it. If not, I tend to default to just let's plug it into the quadratic formula and get this answer quickly. So I'm going to do that here because it doesn't factor. Plugging it in, x equals negative 12 plus or minus the square root of 12 squared minus 4 times 3 times negative 8, all divided by 2 times 6, or 2 times 3 to give me a 6 in the denominator. So I start simplifying things. I get a 240 inside the square root and 6 on the bottom. If I break that up, it turns out that 16 times 15 equals 240. So that if I take the square root of that 16, I'll get a 4 root 15. And all of my values are even now. The 4, the 12, the 6 are all even. So I can reduce this all by 2. So dividing every term by 2, I end up with negative 6 plus or minus 2 root 15 over 3. And because we are trying to graph these points, I am going to do a decimal approximation of both of these values so that I can actually get some idea of where they are on the graph. So if I do the plus and the minus version of my answers, I get approximately negative 4.6 and 0.6. So there's 2 ways I could write my x-intercepts, either using the exact values with the square root in there or the approximate values as a decimal. Okay, so we found the vertex, the axis symmetry, and all the intercepts. We still haven't talked about the absolute extrema, although it should be the vertex. It's just a matter of whether it's the min or max. So we're ready to start graphing this, and when we really graph it, we'll definitely be able to see whether that was a min or a max, and then we'll find that domain and range. Okay, so I've got the vertex. I'm going to graph that. I'm going to graph all my intercepts, and then I know it's a U shape, so it's really just about connecting those dots and making sure that everything is symmetrical along the line x equals negative 2. So you should get an image that looks like this after you've graphed those 4 points and connected them. So now I can definitely see what I was kind of visualizing in my head, that this is opening up, which means the vertex is going to be the absolute. Oh, and I have maximum there. That is the minimum value. It's a typo. So this is the lowest point in the graph. So it is the absolute minimum. And the only thing left to do is look at the domain and range. So parabolas, usually, unless they're like laying on their side or something, their domain is everything, and that is the case here. If I go anywhere along the x-axis, there's no value I can't plug into this. There's no spot where there's a hole or a gap in my graph. So the domain is everything, negative infinity to infinity. The range is a different story because we do have that absolute minimum value. This thing never goes lower than negative 20. So it does actually hit negative 20 because that's the vertex. So my range is going to be negative 20 going up to infinity. Okay, so I found all the information they asked for with this. I have a really good idea of the picture and a lot of the important pieces of this graph. Let's do another one, this time in vertex form. So f of x equals 1/2 times x plus 3 squared plus 5. And we're going to find all the same stuff. We're just using the other formulas. So this one does go a little bit faster, you'll see, because the form that they gave it. Just reminding ourselves the general form, well, not general form, the vertex form is in general a times x minus h squared plus k. And hk is going to be the coordinates of the vertex. So for this one, I can see that the 5 is easy to pick out as my k value. Be careful when picking the h, because remember the general form is minus h, and I got a plus 3 here. So a negative 3 is what is going to be my h, because it's x minus negative 3 that if I'm having to subtract. So h is negative 3, k is 5. That's my vertex, negative 3, 5. My axis of symmetry is the x-coordinate of the vertex, so that's x equals negative 3. Okay? No calculations necessary so far. Next up is the intercepts. So we're going to do these pretty much the same as we did with the last one. Plug in 0 for x, and then plug in 0 for y, and solve. So f of 0, well, that gives me a 0 inside the parentheses there. So if I do some simplifying, plug it in my calculator, I get negative 9 halves plus 5, which gives me a positive 1 half for my intercept there. So the y-intercept is 0, 1 half. Go to the other side now, plug in 0 for y and solve for x. So I will subtract 5 from both sides. I'm going to get rid of the negative 1 half by multiplying by negative 2. So that gives me 10 equals x plus 3 squared. From here, I'm going to square root both sides of the equation. Okay, so don't forget to throw a plus or minus on that root 10, or you won't get both answers, and we need both intercepts. This thing should come back and hit it twice. There are instances where you'll end up with no x-intercept if the vertex is, say, above the line and opening up, for instance. But most of the time we'll get 2. If it's right on the axis, then we'll get just 1. Okay, so last step here is if I subtract 3 from both sides, I'll get 3, or x equals negative 3 plus or minus the square root of 10. So there's my 2 x-intercepts. And so I can write those as exact values, or I can do an approximation for graphing. So this is approximately negative 6.2 and negative 0.2. Okay, so just kind of summarizing everything we found so far. We've got the vertex, the axis of symmetry, the y-intercept, and both x-intercepts. So I'm going to plot all those points, make sure everything is symmetric about the line x equals negative 3. And I get a graph that looks like this. So it's opening down with a vertex at negative 3, 5. And I can see my y-intercepts there. So looking at the graph, it's opening down. The vertex is going to be an absolute maximum value at negative 3, 5. The range, or the domain, again, is everything here. There's nothing I can't plug into this thing. So I get negative infinity to infinity for the domain. For the range, well, this thing is going down toward negative infinity, and it tops out at 5 along the y-axis. That's the highest point. So my range is going to be negative infinity to 5. Okay, hope these helped. There's an example below this video for a little bit more practice with this.